So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over a quick topic test with a collection of some GCSE exam style questions on sequences at foundation level. Now a copy of the questions for you to have an attempt at before watching through this video is available for you to download by clicking on the link in the description, which I strongly recommend you do to see how much understanding you have on this topic. Now, before we get started working through this sequences test, it's worth noting that there is no indication about whether these questions are designed for a non-calculator or a calculator paper. So what we'll do is we'll just make sure we show our full working out, and if we need to use our calculator or can't use our calculator to work out a certain calculation, then we'll simply work through it. So let's get started on question 1. So question 1 says, here is a pattern of calculations, and it says write down the answer to 777,777 multiplied by 999,999. So let's have a look. So looking at this, we can see that the pattern starts with 777, and you can see that we've got 6, 3, and then we introduce a 7 and a 2 somewhere either at the start and in the middle of that pattern. Now it's worth recognizing that each of these numbers all have a single 6 and they all have a single 3, and the only numbers that are being added are 7s and 2s. So what we need to do is just check to make sure we're using the right 7s and using the right number of 2s in this. Now I would say this question would most likely be a non-calculator question. So moving on to continue the pattern, so we've got 7, 7, 7, 7, 7, so we've got 5 7s and then 5 9s, and that's going to be equal to, so we're going to increase the number of 7s, so it's going to have 4 7s, 1 6, and then 4 2s, and then a 3. Now the one that we want, which is the next in the sequence, so that's going to have 6 7s, so 1 2 3 1 2 3, and times 9 9 9 9 9 9. And looking at that answer, well, I'm going to have an extra 7, so that's going to be 5 7s in total, 1 6, and then 5 2s, and then a 3 at the end. So the answer is going to be this. So it's going to be 7 7 7 7 7, and a bit Monica there, and 6, and then 5 2s, and 3. And there is our final answer. Moving on to question 2, it says that a sequence of numbers is formed with 1 1, 2 2s, 3 3s, 4 4s, and so on. And the question is asking us to work out the 100th number in the sequence. So this can be very, very time consuming, so we need to find a very more effective way of answering this question. Now, one way of doing that is using commutative frequency. So here, let's have a look. So if we start with the number, which is going to write NO, and we have our commutative total, which is basically going to see how many numbers we're going to have in the list. So looking at the ones, I've got 1 1. Then looking at the 2s, I'm going to add 2 to the previous CF value. So then that's going to be 3. Then I've got 3, and I'm going to add 3 to 3, so that becomes 6. Then add 4, so that becomes 10. Then add 5. Then add 6. Then add 7. And then if I then just continue the list, so let's just do that there, so number and CF, and then I've got 8, which is therefore going to have 36, 9, which is going to have 45, 10, which is 55, 11, then add 11 to 55, so that's going to be 66, 12, add 12 to 66, which gives me 78, add 13 to that, that's going to give me 91, and then 14 is going to give me 105. So looking at the commutative frequency values, 100 is going to be the number 14. So that there is my final answer. Moving on to question 3, it says here is a linear sequence, and it says the first 2 terms are missing. Describe how the sequence is building up. So the building up is really important because it means we're going in this direction. So basically what we need to write here is that it goes up by 6 each time. Now typically whenever you're describing a sequence, I would always say you should always say what number you're starting with, but that's missing from this, but also it's basically what question 3b is, so I'm not going to mention it in there. But typically if I was given a question to describe a sequence, I would always start the answer with whatever number you are starting with. So moving on to b, then we've got plus 6, so then from here to here that's also going to be plus 6, but going in the opposite direction, that's going to be subtracting 6. So that's going to be minus 3. And then from that, that's going to be add 6, but to go in the opposite way, it's going to be the opposite, which is subtract 6. So this is therefore going to be minus 9. So the first number in this sequence is minus 9. Moving to our next question, question 4, it says here are the second and third terms of a linear sequence. Work out the mean of the first 4 terms of this sequence. So again, looking at this, we can see that the pattern is plus 5. So we can then work out what this number is by doing the opposite, which is take away 5. So that's going to be 7. And to find out what the fourth number is, add 5 to 17, which is going to give me 22. So to work out the mean, I add up those 4 numbers. So 7 plus 12 plus 17 plus 22. I'm going to divide that all by 4. Simplifying the top or doing the calculation, that's going to give me an answer of 58. Divided by 4. Half of 58 is 29, and divide that by 2, so that's going to be half of 29, which is 14.5 or 14.5, whichever you prefer to write it as. So moving on to question 5, it says write down the next term of each of these sequences. Now the key thing to note is that it doesn't mention linear or quadratic sequence, it's just a sequence. So we might need to look at the type of patterns that's being created. Now I would always start by working out the difference. So that's plus 5. That's then going to be plus 7. That's plus 9. That's going to be plus 11. And so looking at the difference between the numbers, you can see that they are all odd numbers. So the next difference is going to be plus 13, which gives me an answer of 49. Another thing you can also spot is that all of these are square numbers. So 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. So this one here is going to be 7 squared, which is also 49. So several ways in which you could get that answer. The next one here, you can see we've got 1, 1, 2, 3, 4, 5, 8, 13. So hopefully you'll be able to spot that this is the Fibonacci sequence. So here, if we add the previous 2 terms, it gives me 2. So 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5, and then 3 plus 5 is 8. 8 plus 5 is 13, and so this number here is going to be 8 plus 13, which gives me an answer of 21. Then moving on to question 6, it says the nth term of a sequence is 7n minus 3. Work out the first 3 terms of the sequence. So here we just need to substitute n equals 1, 2, and 3 into this. So here for the first one, we've got 7 times 1, take away 3, gives me an answer of 4. Then we've got 7 times 2, take away 3, which gives me an answer of 11. And then 7 times 3, take away 3, which gives me an answer of 18. Now I've put that one over there. Then moving on to question 6b, it says which term of the sequence has a value of 109. So for this, what we need to do is make this 109 equal to the nth term. So I've got 7n minus 3 equals 109, and then solve this equation. So 7n equals 112, and so n equals 112 divided by 7, which gives me the answer of 16. Moving on to question 7, it says work out the next term of this quadratic sequence. So for this, if we look at the difference, so that's plus 4, that's plus 6, that's plus 8, that is going to be plus 10. So you might think to yourself, well, what's the next difference going to be? Well, you can notice that the difference is going up by plus 2. So the next difference is going to be plus 12. So that therefore is going to be 46. For the next one, work out the geometric sequence. Now this is where you're multiplying the previous term to get the new term. So here you just need to work out the difference. So 3 to 9, we multiply, not add or subtract. So we multiply by 3. So this term here is going to be 243 multiplied by 3. So either doing long multiplication or typing it into your calculator, we should have the answer of 729. Then moving on to question 8, it says here is a sequence, and it says circle the expression for the nth term of the sequence. Now this is a linear sequence, so let's first of all work out the difference. So it's going to be minus 2 So that means minus 2 is in the formula. Then what you need to do to get from minus 2 to 15 is you need to add 17. So I'm looking for this. Now in its current form, none of the 4 options match, but if I swap these two things around, I get 17 minus 2n, which is the third option. Then moving on to question 9, it says that the nth term of a sequence is 2n plus 3 and the nth term of sequence B is 5n minus 4. Work out two terms that appear in both sequences. So for this, what you need to do is to write down all the terms and see which one appears in both lists. So if I write down the first term of this sequence, so here it's going to be 2 times 1, which is 2, plus 3, which is 5, and then I'm increasing the terms by plus 2. So it's going to be 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, etc. Then with this one here, I've got 5 times 1, 5 times 1, which is 5, take away 4, which is 1, and the difference is 5. So I'm going up in 5, so that's 1, 6, and then 11, 16, 21, 26, 31, 36, etc. And then you're just circling which ones appear in both. So 11 appears in both and 21 appears in both. So they're a set of possible answers I could have. Now, if you've gone out the boat and you've thought of any another two numbers, then as long as it is in the sequence of 10n plus 1, that will always appear. So basically from this, any sequence that comes in this, so for example, when n equals 1, I'm going to get 10 times 1, which is 10, plus 1, which is 11. When n equals 2, 2 times 10 is 20, plus 1 is 21. n equals 3, 3 times 10 is 30, plus 1, 31, 41, etc. So any two of those numbers will be absolutely fine. Moving on to our last question, question 10, it says the nth term of sequence P is an plus b and the nth term of sequence Q is bn plus a. Show that the sequence both start with the same term. So here the first term is when n equals 1. So if I then sub n equals 1 into P and Q, well, for P it's going to be a times 1 plus b, which is a plus b, and for Q it's going to be b times 1 plus a, which is b plus a, and you can see that these two things here are the same. So the first term for each of those sequences is going to be the same. Moving on to our last question, it says for 10b, it says the second term of sequence P equals the third term of sequence Q. Show that a equals 2b. So for this bit here, what we're going to do is we sub n equals 2 into P. So from this we've got, so for that we're going to have 2a plus b, and that equals, and then for this bit here we sub n equals 3 into Q. So that's going into this. So we've got 3b plus a. And then what we need to do is just simplify this. So if I take all of this to that side, I'm going to end up with a minus 2b equals 0. And then from that, if I take the 2b over to this side, I end up with a equals 2b, which is exactly what they wanted me to show.